Okay, today's topic is going to be about solving logarithmic equations, a topic taken from college algebra. My name is Kurt Overhiser, and I will be your guide as we look through 3 or 4 examples of how to solve equations involving logarithms. First of all, let's write down some of the steps that we're going to be using. Pretty simple, it's a 3-step process. Step 1 is to isolate the logarithm. And you're going to use some of the logarithm rules if needed. Step 2 is to convert to exponential form. Step 3 is to simply solve for x. Okay, so let's see how we're going to use these 3 steps and to solve some problems. Our first example is going to be solving this equation. Six multiplied by the base 2 logarithm of x plus 15 equals negative 3. And step 1 says isolate the logarithm being this part right here. This is what we need to isolate. So if you can kind of, if you look at, I'm going to write something in the margin here. It's going to be this. 6y plus 15 equals negative 3. I'm sure you know how to solve this equation for y. It's a beginning algebra problem. And all you do is you subtract 15 from both sides. And you get 6y equals negative 18. And then if you divide both sides by 3, divide both sides by 6, you get a negative 3. And that's the answer for that little auxiliary equation. And I'm pointing this out because this equation that I have written in the margin here relates very much to our logarithm equation that we're trying to solve. So we do the same steps. We have to in order to isolate the logarithm as prescribed in step 1, we have to first subtract 15 from both sides. So you get 6 times the base 2 logarithm of x equals negative 18. Divide both sides by 6. So the base 2 logarithm of x is equal to negative 3. And that is, this is all step 1. Now we're ready to go to step 2. Step 2 says to convert to exponential form. So with exponential form, you first identify what the base is. 2 is the base. And then whatever the logarithm is equal to, in this case negative 3, that's going to be your exponent. Because remember that logarithms are exponents. So converting this to exponential form, we get a base of 2 raised to the negative 3 power, and then set that equal to what you're taking the logarithm of. In this case, what's in the parentheses is x. So that's how you make the conversion. And then once, so we're on to step 3, but 3 is already done for us. Because when we convert it to exponential form, upon completing step 2, x was already solved for. So if you just take 2 to the negative 3 power you get x is equal to 1/8, or as a decimal, 0.125. Okay, and that's the answer. So really, most of our work dealt with steps 1 and 2. We didn't even have to. Step 3 in this example came to us for free. So let's look at another example, example 2. Example 2, we're going to solve the base 5 logarithm of 8 minus 3x is equal to 2. So to isolate the logarithm, this step, number 1, is already done for us because there's nothing more to do here, because this is the entire logarithm that we're supposed to isolate. So step 1, we'll say here is already done. So we go to step 2, where we have to convert to exponential form. So let's see, the 5 is the base, 2 is the exponent. So we take 5 to the second power and set it equal to 8 minus 3x. So that basically tells us that 25 is equal to 8 minus 3x. Now to step 3, we have to solve this equation for x. That's a simple beginning algebra equation. If we subtract 8 from both sides, we get 17 is equal to negative 3 times x. And then dividing both sides by negative 3, you get x is equal to negative 17 thirds. Which is the decimal is negative 5.6 repeating. And then that is our answer for number 2. Okay, now we're going to look at example 3. Example 3 is a little bit more challenging. We're going to solve this equation. The base 10 logarithm of x minus 3 minus the base 10 logarithm of x plus 1 equal to negative 1. Okay, so if you look at step 1, remember, was to isolate the logarithm, use logarithm rules if needed. Here we have 2 logarithms. So before we can convert to exponential form in step 2, we have to use the rules of logarithms in order to express the left-hand side of this equation as a single logarithm. Right now it's in 2 logarithms that we're subtracting from one another. So what we'll do is we'll make use of this rule. See if you remember this log rule. Log rule that we're going to be using, I'm going to put here on the margin, is the base b logarithm of x divided by y equals the base b logarithm of x minus the base b logarithm of y. Hopefully you've learned that rule. So when you subtract 2 logarithms in the same base, you can express it as this single logarithm right here, the base b logarithm of x over y. So we're going to apply that rule here, and we're going to get the base 10 logarithm of a fraction and set that equal to the number negative 1. And if you look at what's playing the role of y right here, if you think of all of this part right here as your y value, then y goes in the bottom of the fraction. So I'll put x plus 1 here, and then what goes on top is x minus 3. Okay, so now the logarithm is now isolated, so that's step 1, using one of the logarithm rules. Now we're going to go to step 2, where we convert to exponential form. So the 10 is the base, negative 1 is the exponent, and then set that equal to x minus 3 over x plus 1. Now we're on to step 3, where we can solve this equation for x. 10 to the negative 1 power is the same as 1 over 10. And what we can do here is we can cross multiply. So we get x plus 1 equals 10 times x minus 3. And then if you distribute the 10, you get x plus 1 equals 10x minus 30. And then we have to solve for x here. So we're going to do that by doing 2 steps in one. We're going to add 30 to both sides of the equation at the same time that we're going to be subtracting x from both sides. So we get 31 is equal to 9x. And then so x is equal to 31 over 9. Which as a decimal is 3.4 repeating. And then that is our answer right here for this problem. Now I want to call your attention to something, because I'm going to make for example 4, we're going to make a slight modification to example number 3. We're going to take the same problem and we're going to solve the base 10 logarithm of x minus 3 minus the base 10 logarithm of x plus 1, and then instead of setting it equal to negative 1, we're going to set it equal to positive 1, because there's a lesson to be learned by doing this. So step 1 is the same. Use the same rule of logarithm and to isolate the logarithm, and we get the base 10 logarithm of x minus 3 divided by x plus 1 is equal to 1. Step 2, we're going to convert. So we get 10 to the first power is equal to x minus 3 divided by x plus 1. And so our last step, step 3, where we have to solve for x, we're going to cross multiply here, and we get 10 times x plus 1 equaling x minus 3. That's what we get when we multiply both sides by x plus 1. Well, next we'll distribute the 10. We get 10x plus 10 equaling x minus 3. And then we're going to do 2 steps in one again, where we subtract x from both sides at the same time that we're going to be subtracting 10 from both sides. So if I subtract x from both sides, I end up with a 9x. And then if I subtract 10 from both sides, I'll end up with a negative 13. So I get 9x equals negative 13, or you can say x is equal to negative 13 over 9. Okay, and you think that at this stage that we're done, because we found an answer, but this is what the lesson that we need to learn is. If you look at this as a decimal, negative 13 over 9, you get negative 1.4 repeating. And if you try to take this negative 1.4 repeating and try to put it in the original equation, you'll end up with, if you try to take negative 1.4 repeating, like if you put it right here and subtract 3, or if you add 1 to it, you end up with the logarithm of a negative number. So you plug in, but you cannot take the logarithm of a negative number. It's not defined when you do that. So logarithm of negative number equals undefined. So in this case, this is negative 1.4. We're going to cross out because it doesn't fit the original equation. So we say that there is no solution in this case, and that would be our final answer here, is no solution. We think we get a solution, but when you deal with logarithms, you have to make sure, just like you can't take the square root of a negative number, you can't take the logarithm of a negative number. If you look at example 3, if we take our answer 3.4 repeating and then try to plug it in, you see that we're okay, because 3.4 repeating minus 3 is still positive, and if you add 1 to it, it's still positive, and the logarithms of positive numbers always exist. So that means example 3 does have a solution, and it is indeed 3.4 repeating. Okay, so hope you enjoyed this lesson, and good luck in your studies. Take care. Bye-bye.